In arithmetic sequences, you have a common difference where you are, or the sequence is adding or subtracting by the same amount every time. In a geometric sequence, you have what's known as a common ratio, where the difference from one term to another is a multiple, right? So you are timesing by a certain amount every time. So for example, 2, 4, 8, 16. In each case, you are timesing by 2. It's going to be the same number every time. It's just now you're multiplying. That's what differentiates or distinguishes geometric sequence and arithmetic sequence. One has a common ratio, the other one has a common difference. Because geometric sequences have a common ratio and they are split, or they are, each term is separated by a multiple, the formula for the nth term is going to be different. We saw a plus n minus 1d. In this case, you have ar to the power of n minus 1, where a is still your first term, but now r is your common ratio. Okay, cool. So let's have a look at this example. 3, 6, 12, 24. Each term, or to go from one term to another, you have to multiply by 2. So r is 2. Your first value is 3. So to work out the 10th term, u10, we would do 3 times 2 to the power of 10 minus 1, or 3 times 2 to the power of 9, which is 1536. Okay, the nth term would be 3 times 2 to the power of n minus 1, and you would just leave it like that. So that being said, can you try B for me, please? So in this case, A is 40, and R is minus a half. That's what you're timesing by every time. So to work out u10, you do 40 times minus a half to the power of 9, which is minus 5 over 64. Or to get the nth term, you would do 40 times minus a half to the power of n minus 1. Okay, from here, you can use your laws of indices to simplify this as much as possible. So let's split 40 into 5 and 8. And then let's split 8 into 2 cubed. Like this. So this now becomes minus 1 to the power of n minus 1 times 5 over 2 to the power of n minus 4. But I don't think you don't need to worry too much about that. I think as long as you get this, you should be fine. Okay, so let's have a look at this scenario. It says the second term of a geometric sequence is 4, so u2 equals 4, and the fourth term is 8, u4 equals 8. Given that the common ratio is positive, find the exact value of the 11th term. u11 equals question mark. Okay, here's how we work through this. Let's use this example, this one, 3, 6, 12, 24. The first term is a. The second term is AR. The third term is AR squared. This is AR cubed. And so on and so forth. So with that same logic, the U2 will be AR. And U4 will be AR cubed. So this is equal to 4. This is equal to 8. That's how we set up our simultaneous equation. 1, 2. Now, if we do 2 divided by 1, that's AR cubed over AR equals 8 over 4. Which means R squared is equal to 2. Which means R is equal to root 2. Cool. Now when we substitute that back into one of our equations, a root 2 equals 4. So a equals 4 over root 2. And when you rationalize it, you end up with 2 root 2. Okay. It's asking for the 11th term in the sequence. So you're going to do a 2 root 2 times r root 2 to the power of n minus 1, which is 10. And when you sub that in your calculator, in surd form, you get 64 root 2. That's how you do a question like that. So, question 8. I want you to give that a shot for me, please. Okay. If you happen to have the Edexcel book, example 10 on page 68 will be very useful in this scenario. So for A, it says, show that x cubed minus 4x squared equals 0. Here's what you can do. You can equate the difference between term 1 and 2 and term 2 and 3. So let's say U2 over U1 equals U3 over U2. That's kind of like a formula which you can use. Okay, now that I've given you this, if you want to give this question another shot, feel free. From here, you want to express, or you want to figure out what U1, U2, and U3 are. This is U1, that's U2, that's U3. So U2 over U1, 2x over 8 minus x equals x squared over 2x. From here you can cross multiply. 4x squared equals 8x squared minus x cubed. And now x cubed equals, minus 4x squared equals 0. There we go, we've shown it. Part B. Find the value of the 20th term. In order to do this, we need to find x first. So if we factorize, we get x equals 0 and x equals 4. It says in the question, x has to be greater than 0. So x equals 4 is our solution, which means our first term, U1, 8 minus 4 is equal to 4, and U2 will be 2 times 4, which is 8. To go from U1 to U2, we have to times by 2, which means A is equal to 4 and R is equal to 2. The 20th term, therefore, will be AR to the power of 19. 4 times 2 to the power of 19. So let me rewrite that. Times 2 to the power of 19. So the power applies to the R. This gives us 2097152. Okay, Part C. State with reason whether 4096 is a term in the sequence. Okay. We know that our nth term is 4 times 2 to the power of n minus 1. We're trying to work out if 4096 is part of the sequence. So we're going to make our nth term equal to 4096. And then we're going to solve for n. If n is an integer, it's part of the sequence. If n is not an integer, it's not part of the sequence. Because our values for n are integers. N equals 1, n equals 2, n equals 3. At no point do we do n equals 1.5. Okay, so let's rearrange. Let's divide by 4 first. And we get 1024. Here, we're going to use logs. So n minus 1 equals log base 2 of 1024. So n minus 1 equals 10. So n equals 11. Since that is a integer, that means 4096 is the 11th term of the sequence. And there you go. That is how you do geometric sequences.